This is a look at the nature of a narrowband signal, and what we're going to be using here is an HP8566B spectrum analyzer, somewhat dated but very popular in its time. And we're going to be looking at the exact same signal that we were using in the demonstration when we were tuning the radio to a narrowband station. And right now, as a close-up of the screen, we'll see that we're tuned to 49 megahertz. We've got a 10 megahertz sweep from 44 to 54 megahertz. 49 megahertz is the center frequency, and there is no signal. All we're looking at is the noise floor of the analyzer. Now we're going to look at our signal source. Right here, same one we used the other day on the other demonstration. We have 1 megahertz frequency. We are set for square wave, and the RF is turned off. Now I'm going to turn the RF on. Come back and look at our screen, and what we can see here is we can see, if we look very closely, we can see the frequency components. We've got a component every megahertz if we look closely, and I'm going to go ahead and note following thing: the frequency components are totally stable. Every 2 megahertz you see a big hit, and every 1 megahertz, or every 1 megahertz in between the 2 megahertz, you see a small hit. Those are the odd harmonics that are large, and the even harmonics that are small. That's a characteristic of a square wave. So that this signal is easier to see, to make the noise floor go away, I'm going to go over here to put the max hold button on. Okay. And what we see is the noise floor basically just becomes a straight line, and we can look at the signals without looking at that, and you can see the low-level signals, the low-level even harmonics, and the higher-level odd harmonics. But even if I go off of max hold back to clear right, we can see the frequency components are stable. They're at the same frequency, they're at the same level, and you can see how narrow the components are. The moment you tune off of one, you go from getting interference to getting no interference, which we saw with the radio. So that is a demonstration of what a narrowband signal looks like. Those are the harmonics of a 1 megahertz square wave. And that's it.